Moving on to proposition 45, we're going to construct in a given rectilineal angle a parallelogram whose area is equal to a given rectilineal figure. And ABCD is going to be the given figure, and E the given angle, so we'll draw these out. So there's going to be nothing special about ABCD. In this construction, we're just going to use an arbitrary parallelogram. So there's going to be nothing special about ABCD. This is going to be just some random quadrilateral. This will be ABCD. And E is going to be the given angle, so we'll let this be E over here. It's going to be the given angle. Thus, it is required to construct in the given angle E a parallelogram equal to the rectilineal figure ABCD. So we're going to construct a parallelogram using this angle whose area is equal to ABCD. Let DB be joined. We'll do join DB. And let the parallelogram FH be constructed equal to the triangle ABD, this triangle generated over here, in the angle HKF, which is equal to E. So what we're doing is producing a parallelogram using the given angle E, whose area is equal to the given triangle, which we can do by proposition 42. So we'll generate that parallelogram over here. And the way these angles are going to work is that this angle is going to be equal to this angle over here. And I'll just do the labeling here. KH, F, and G. So we've constructed a parallelogram FH equal to the triangle ABD in the angle HKF equal to E. Let the parallelogram GM equal to the triangle DBC over here, this other triangle, be applied to the straight line GH in the angle GHM, which is also equal to E. So we're going to build upon the given straight line a parallelogram whose area is equal to this triangle DBC over here, which we proved in the previous proposition. We'll go ahead and build that parallelogram over here. And in terms of labeling, this angle is going to be equal to the angle E. This is going to be M and L. And just to review, let the parallelogram GM equal to the triangle DBC over here be applied to the straight line GH in the angle GHM, which is equal to E. Now this is the main construction, and we're going to spend a lot of the rest of the construction proving certain features about this diagram, namely about certain line segments being in line with other line segments. Then, since the angle E is equal to each of the angles HKF, which is this, and GHM, therefore, the angle HKF, which is over here, is also equal to this angle over here. Those two are equal by combination 1. And next what we're going to do, given that these two angles are equal, we're going to add to each the angle KHG, which is over here. Just add in that angle. Therefore, FKH and KHG taken together are equal to the angles KHG and GHM taken together. That's clear. But the angles FKH and KHG are equal to two right angles by proposition number 29. And why is that true? Well, we have KF and HG, which are parallel, being cut across by KH. Therefore, this angle and this angle together are two right angles. Thus, with a straight line GH, and at the point H on it, there's two straight lines KH and HM not lying on the same side make the adjacent angles equal to two right angles. So what he's saying is that now we know that this angle and this angle are together two right angles, and they're on adjacent sides. Therefore, KH must be in line with HM. And that's the conclusion. Therefore, KH is in a straight line with HM by proposition 14. And since the straight line HG falls upon the parallels KM and FG, the alternate angles MHG, which is this angle over here, and HGF, where's that? That's going to be over here. These are alternate angles. This angle is equal to this angle. Those are alternate angles, since we have this parallel line and FL being cut across by HG. And then we're going to do something similar. We're going to let the angle HGL be added to each. Therefore, the angles MHG, where's MHG? That's over here. And HGL, this one over here, are equal to two right angles. Again, we know this by our study of parallel lines. And we're going to do something similar. We're going to add in the angle. And based on our study of parallel lines in proposition 29, we have HM and GL being cut across by HG. Therefore, this angle and this angle will sum to two right angles. From this, we conclude, therefore, the angles HGF, which is this one over here, and HGL, this one, are together also equal to two right angles. And, same argument as before, therefore, FG over here is in a straight line with GL, since the adjacent angles are together two right angles. That's proposition number 14. And since FK is equal and parallel to HG, and HG also to ML, KF is equal and parallel to ML. So these two are equal and parallel by proposition 30, and the straight lines KM and FL join them at their extremities. They join equal and parallel lines. Therefore, K to M and F to L are also equal and parallel. That was proved in proposition 33. Therefore, this whole thing, KFLM, is a parallelogram. And since the triangle ABD up here is equal to the parallelogram FH over to the left, and this other triangle, DBC to GM, this parallelogram on the right, the whole rectilineal figure ABCD, this quadrilateral up here, is equal to the whole parallelogram KFLM.